Hi everybody, welcome back. We are going to continue on kind of the introduction to motors. One of the first things we need to have just the basic idea of is what Newton's first law was. And that's that an object in motion is going to stay in motion, or an object at rest will stay at rest. And the big part of that is kind of how that finish it off until a force is acted upon it to oppose that. So if we're in motion and we have a force to oppose it, it could be friction, it could be something that stops it. An object at rest, it wants to stay at rest until there's a force acted to move it from that state. But that's where it wants to stay. This is also a law of inertia. And inertia is just the tendency of an object to either stay in motion or to stay at rest. So if we think about this like I have a box sitting on the ground, and that box, say it's a 10 kilogram box, it wants to stay at rest. There's nothing, if there's no forces being acted on it, and we're going to kind of ignore gravity, like we're just going to kind of leave it as simple as, we're not going to talk about gravity and friction and windage and all those things. We're just going to leave this at its kind of fundamental for right now. That 10 kilogram box, it wants to stay there. Now, if I act on it with a force and it starts to move, if this is a frictionless surface, we kind of remove all those things, just keep it simple. It wants to stay in motion. So if it's moving at 15 meters per second, it wants to stay moving at 15 meters per second, and it will move indefinitely. This is what its law says. It will move indefinitely until there's a force acted on. That's when friction and all those other things come into play. Okay? And what's important when we think, so the law of inertia is another name for his first law. And where that comes into play is if I compare forces of two objects, say one is this blue is not showing up very well. That's a 10 kilogram box, and we're going to say this is a 100 kilogram box. Okay, what are the forces if I were just to compare these two? Which one would have a higher inertia? The 10 kilogram box or the 100 kilogram box? Well, if we think that the higher the mass, then the higher the inertia. You could say, Jason, what on earth does this have to do with motors? Well, think of this as two different motors. Kind of all things being similar. We'll get into later about voltage and how things can be different if I change different parameters with this motor, but let's just keep it at step one, because that's where we're at. If this was a 10 kilogram motor, and this is a 100 kilogram motor, so this is 10 kilogram motor, and this is a 100 kilogram motor. When I start each of these motors, which one's going to have a higher inertia? Which one wants to stay there? So a 10 kilogram compared to the 100. You can relate that to current. What is the current going to be at startup from the 10 kilogram to the 100 kilogram? Well, all things being equal, because an object at rest wants to stay at rest, an object in motion wants to stay in motion, the 100 kilogram motor is going to have a higher inertia purely on the fact that it is a higher mass. So this is kind of just step one. We'll keep going with this. Hope this has helped. This is just the start, just so we can understand how some of the laws of physics, some of Newton's laws, help us understand what a motor is actually going to do. Hope this has helped. We'll see you in the next one.